Alright guys, welcome to another video, the LeetCode 30 days, then 60 plus days LeetCode problem solving. So today we are going to tackle reverse integer and we're going to try to solve this problem, and then we're going to test it on LeetCode. So the question reads, given a signed 32-bit integer x, return x with its digit reverse if reversing x causes the value to go outside the signed 32-bit. That's the range from 2 to that's negative 2 to the 31 to 2 to the 31, right? Yeah, that should be 2 to the 31 minus 1. Then return 0, right? And then assume the environment does not allow you to store 64-bit integers, signed or unsigned, right? So example, you get an input like this, the 1 to 3. When you return, you return 3 to 1. Example 2, input will be negative 1 to 3, then negative 3 to 1, so on and so forth. So I think this one is a bit straightforward. So first of all, we need to check. So we need to check for sign and check for sign, check for sign. But because what we want to do is convert the so we'll do convert the integer, right? So I think we'll do something like we'll do a check. Okay, see. So so what we want to do is we want to traverse. So we want to loop through the integer so that we get the last digit and put it in the new integer. Yeah. So in essence, what I want to do is I want to go through something like a loop in such a way that each time we go through a loop, we remove this one and then we put it in a new variable called result. So first of all, we define result. So it's going to be an int result equals to 0. Yes. And then we need to loop through. Now this is not a string, so we cannot use a for loop here. However, we can use a while loop. So use a while loop because I had solved something similar like this, so this one is a little bit easy. I think we did some integer in our last, I think probably our first or second series. If not, then it's probably on my own that I did something at a single number, something like that. Yeah, anyway, so in essence, in order to loop through an integer, one of the things I discovered is that you can divide the integer by 10, sorry, to be able to, and then what you have is the remainder of this integer will definitely be the last number. So for example, if you have 123 divided by 10, we have 12.3, right? So that remainder, that point, is the last number. And so we can do that. So we can say, so we can do that, right? So we can loop through. So let's just all loop through. Then we'll have a condition. We'll define the condition later. Loop through until condition is met, and then we want to get the last digit, use the modulus add it to the result. But yeah, so add it to the result. Yes. So let's loop through this. So how do we loop through? So we want to take x, I think it's going to be some kind of a while loop. So until x is equals to something. So we're looping through this, right? And each time we loop through this, since we're dividing, in order to do this, we have to do the modulus, right, of n. So each time we divide through, right, we need to reassign the remaining value. So for example, you have 123 divided by 10, we have 12.3. We'll take this one and put in result. And then this remainder, we need to make sure we reassign it back to x. So x becomes 12. And then it goes through the loop again. So I think since that is being done and we realize that we can have both negative and positive, we can just make sure that while x is not equal to 0, right? So this carries both the negative and the positive integers, and then we can do the get the last digit, use the modulus, and so we can do this. We can do result is equal to result times 10. Yeah, so that there it is. And this is correct because if you look at the result, right? So if result is 0, yeah, so it'll be 0 times 10, which is 0, times the modulus of 3, so which will be 3, right? So that will be 3. However, if result is 3, I want to take 12 divided by 10, so it will be 3 times 10, which is 30, because when we are adding, it comes, so result becomes 3, right? When we want to add the 2, we don't just, there is no proper way to like concatenate it, right? The proper way to do it is add it in the form of, in such a way that it's at the end. And in order to do that, basically you just add, you multiply this existing number by 10. So if it's 3 there, you do times 10, which will be 30. Then you add the remainder, so plus 2, right? And so you're going to have 32. So you realize that, and if you do the same for 1, then it's going to be result equals to 32 times 10, which is equals to 320 plus 1, which now becomes 321. So you see what happens there, right? So this is really good. So this is the idea behind that. And then, yeah, we now have to just add the remaining numbers back to x. So not assign, not add, assign the remaining numbers back to x. So it will be x equal to x divided by 10, right? That's interesting. You can try to result. Can return result, right? Yeah, let's use something like, let's start something simple. 351, that's good. Let's move the sign. Okay. So let's do the, I think, yeah, that's good. Let's say 9. Let's continue. Okay. Oh, okay, yeah. Okay, so this number is greater than 2 to the negative 2 to the 31. This number is greater, and that's why we're having this distorted output there, because it's trying to convert, it's rounding down, it's rounding to the integer form. So to avoid the error, so the machine does that. So just somewhere here we need to check if the number at result before computing is greater than 2 to the x, 2 to the 31, or less than negative 2 to the 31 minus 2, yes, negative 2 to the 31. So we need to return early by checking if result, but is it the result? Because it will be result times 10. It will be result times 10. Now, why? Because it's not the result which is the problem here. Result times 10. Yeah, because this is what we do, right? This is the output. It's the output. I think if we do this, right? So if we do something like system.out, system.out.print times 10. Yeah, it even complains numeric value overflow. Yeah, so it complains. If you do, I think if you remove 1, yeah, so it should just have a 0 in front there. So that's the case. Yeah, so if we have that addition, it overflows. Yeah, so when that overflows, then that it becomes more than the integer. So this becomes less than negative 2 to the 31. So basically, if result times 10 is greater than 2 to the 31 minus 1, or less than, let's just put, so let's do it mathematically correct. So basically we need to make sure that result is within this range, yeah, every time. So result is within this range. No, sorry. Yeah, result is less than. And less than. Oh no, sorry, greater than. So result has to be less than. Yeah, okay, yeah. No, it's greater than. If this is greater than result, and result is greater than Yeah, negative 2 to the 31. So we'll do if function, I think result times 10 is, so we want to do an early return, so we're taking a negative of this. So if result is rather greater than, so math dot power 2 to the 31, so it says it is supposed to be correct, but it's giving me a warning. I don't think this will work either. Let me just continue it. I think this is correct, but result, yeah, something like that. Yeah, but it's giving me a warning, or result is less than blah, blah, blah. So we have to return 0 because that's the condition. Yeah, these are examples of condition. Yeah, it says, yeah, then return 0. So if the 32-bit integer is not within this range, then return 0 to go outside the 32-bit range. Yeah. So let me see that again. I think it's still going to give the same answer because of that error. Yeah, it's still giving the same answer. I think it's remove if condition is always false, but that's not supposed to be the case. Let me see something with regarding what's power. It returns a double, and this is an integer. So let's put this as 0. Yeah, there you go. Let me see. Yep. So if that's the case, then we just return that. Okay. Still giving the same answer. That's weird. Oh, this is and. Oh, that's also it. So if the result is greater than math.var, right? Minus 1. Minus 1, yeah, minus 1. So we have something like this. Because this is the upper, negative 2 here. It's not plus 1. Yeah. So yeah, sorry. Bit rusty. So yeah, that should work. Let's try that again. Yep, there we go. And so if I reduce 1, that then becomes within the range. And so yeah, it should iterate properly. So if we do, that should be a solution, right? Yeah. Okay, let's check this out. Reverse. Right. Let's check outcome. Internet is still on, yeah, it's still on. It's a bit slow, but still on. Yep. Internet connection, it's a problem, yeah. Connection is a problem. So yeah. Okay. Let's this is so not cool. Why? What's happening? Here we go. So sorry for the delay. Say pass test case 1, test case 2, test case 3. Let's attempt to submit. Oh, okay. That's good. Excellent time complexity. Wow, there's someone less. What the hell is this? 0 millisecond of one time. Wow, okay. So this is also not bad, not bad. Yeah, so it's a good balance between runtime and memory, so that's good. Yeah, so that's the solution for today for these LeetCode questions. I think for the next videos, I might be able to solve multiple questions, especially ones that allow us to go quick like this. So we can definitely, take more questions.